Now let's take a look at the knapsack problem. In this problem, we are given several items. Each item has a value and a weight. And we are to find the number of items that can be included such that the total weight is less than or equal to the limit, and the total value is as high as possible. A knapsack problem is described in the textbook. A U.S. shuttle is to be sent to a space station in orbit around the Earth, and 700 kilograms of its payload are set aside for experiments designed by scientists. Researchers around the country apply for the inclusion of their experiments, but they must specify the weight of the equipment they want taken into orbit. A panel of reviewers then decide which proposals are reasonable, and these proposals are rated from 1, which is the lowest score, to 10, the highest, on their potential importance to science. As you can see in this table, each experiment has a weight and has a rating that was assigned by the panel of reviewers. For example, number 1, cloud patterns, has a weight of 36 kilograms and a rating of 5. Number 2, speed of light, the weight is 264 and has a rating of 9, which is close to the highest score. How do we choose as many experiments as possible such that the total of their ratings is maximized and the total weight does not exceed 700 kilograms? In this spreadsheet, we have the 12 experiments. Column B represents the ratings, and column C we have the weights. Now, one way to solve this problem would be to simply go over each item and select them, and making sure that the total weight is less than 700. So here in this spreadsheet, for example, if I select the first one, the second one, and the third one, notice that so far we have 488 kilograms, and the total rating is 20, which is the sum of these numbers here, 5, 9, and 6. If we keep going, selecting one more, now we are over 700 kilograms. So selecting these first five experiments did not work. Now I could have chosen the first, second, third, fourth, and then notice that experiment number 6 has a weight of 7. I can still fit that one in there. That gives me a total of 698 kilograms with a total ratings of 34. Now we try to find another selection. For example, I could choose, if I choose the highest one, here 264 kilograms, and it has a rating of 9, seems reasonable to choose that experiment. And then choosing another experiment that has high ratings, we're already at 368. Now we have 556. $621. Now we are 1 kilogram above the limit, so that's not good. And we can keep trying to select the items. Now if you look at what we're doing here, we're simply selecting items from those 12. Now if you remember the previous problem that we studied with the matching problem, we were permutating the pilots. In this case, we're not permutating the experiments. We're simply selecting experiments. We can select 1, 2, 3, up to 12. Now here's another spreadsheet. This time we include items according to the ratio. We introduce an extra column here. It's the rating divided by weight. Now if we choose the items with the highest ratio, so if we go down the list, this is what we have. 49, the total ratings, which is a pretty good number so far. adding this 10th experiment here, then that goes over 700. So in this case, we selected experiment 6, 12, 1, 8, 9, 11, 5, and 4, and that gave us a total weight of 542 kilograms and total ratings of 49. Now, one systematic way of selecting the experiments would be simply going through each experiment and either selecting or not selecting it. And we can do this with just one element, two elements, three elements, and that brings us to the concept of sets. Now, this is a set of 12 experiments, and we are simply taking some of those elements from the set, and that's called a subset. The definition of set is collection of objects, also called elements of members of the set. A set can be written by its description. For example, here, A is a set of vowels. In roster form, the set of vowels becomes simply A, E, I, O, U between brackets. Or we can write the set in set builder form. The set of vowels, or the set A, is any element that here represented by X, where this element is a vowel. Now X here means all elements, colon here represents such that, and then the description of what that element must be. So this is simply one way to describe this as an analogy is as think of a set as a big bag or a big bucket, and then you reach your hand inside the bag and grab an element. And then you ask yourself, what is this element that I have in my hand? Then the condition or the description is right here. So you grab an element, and that element must be a vowel. So that's a way to describe the set. Now here's a symbol that represents belongs to. So this means A belongs to capital A. A is an element of A. Now this symbol here represents subsets. Capital A is a subset of capital B, which means A is a subset of B. This means all the elements of set A are also elements of set B. Here's a similar symbol, but now it means contains. A contains B, or simply means B is a subset of A. A null or empty set contains no elements. Here's a symbol for empty set. Now let's go back to the knapsack problem. The set of experiments corresponds to the set 1 through 12. We call it U here in this case. And each selection of experiments will correspond to a subset of U. For example, with this subset here, T, 1, 2, 3, 4, and 6 corresponds to our first attempt to solve the problem. As you can see here in this spreadsheet, 1, 2, 3, 4, and 6. So these selected experiments form a subset of the 12 experiments. Now we have a formula to compute the number of ways we can select a subset. The number of distinct subsets of a set with n elements is simply 2 to the nth power. Let's take a look at this example here. Suppose we are given this set of 4 letters, T, A, P, E. Let's go ahead and list all the distinct subsets of this set. Here we have the subsets with 4 elements, T, A, P, E, which is the original set itself. Now the subsets with 3 elements, TAP, TAE, and so forth. Now the subsets with 2 elements, the subsets with 1 element, and then the empty set, which is also a subset of the original set. The total number of subsets is 2 to the 4th power, since the original set has 4 elements. That gives us a total of 16 subsets.